For our project, we did research on the history of the graphic user interface. Today, almost everyone in the developed world interacts with personal computers in some way or another. We use them at home, at work, for entertainment, information, and for tools to increase our knowledge and intelligence. It's basically assumed that whenever you sit down to use your computer, that it will operate with a graphical user interface. And we expect to interact with it primarily by using a mouse and launching programs simply by clicking on icons and manipulating windows on the screen. And what we'll be talking about is why the computers actually came to adopt the GUI as their primary mode of interaction and how it's evolved to be the way it is today. Like many developments in the history of computers, some of the ideas for the GUI computer were thought of long before the technology was even available to create the machine. And one of the first people to express these ideas was Vannevar Bush. And in the early 1930s, he first wrote of a device called the MEMIX, and he envisioned it as looking like a desk with two touchscreen graphical displays, a keyboard, and a scanner. And it would allow the user to access all of human knowledge by using connections that are really similar to how we use hyperlinks today. At this point, the digital computer had not been invented, so there was no way for such a device to actually work. And also, Bush's ideas were not really read or discussed that much at the time. In 1945, Bush went back to all of his original ideas in an article and wrote them into an article called As We May Think. And this was published in the Atlantic Monthly. And it is an essay that inspired a young man named Douglas Engelbart. And it inspired him to actually try and build this machine. And Douglas completed his degree in electrical engineering in 1948, and then he settled down in a job at the NACA, which is the forerunner of NASA. And when he was on his way to work one day, he kind of had an epiphany and realized that he didn't want to use his engineering skills to work on small little projects that would only benefit a few people. He wanted to build something that would benefit all of humanity and mankind. So he went back to Bush's essay and started thinking about ways that the machine could be built and how it would augment human intellect. And so he used his experience from working in the war as a radar operator, and this made him envision a display system built around cathode ray tubes that would allow the user to build models of information graphically. He went and got his PhD in 1955 and got a job at the Stanford Research Institute, and he received a lot of patents for miniaturizing computer components. And then by 1959, he had earned enough recognition to receive funding from the U.S. Air Force to work on the idea. And in 1962, Douglas published his ideas in an essay titled Augmenting Human Intellect. And in this essay, he argued that digital computers could provide the quickest method to, quote, increase the capability of a man to approach a complex problem situation, to gain comprehension to suit his particular needs, and to derive solutions to problems. He envisioned the computer not as a replacement for human intellect, but actually a tool for enhancing it. And one of the first examples he described for this technology was of an architect designing a building using something similar to the modern graphical CAD software. So for 1962, this was a really big leap in thinking. And because the only computers that existed during this time were these huge monitors, and basically the users would just have these little punch cards, and that's the only way they could interact with the computer. And this was called batch processing. And basically the computer would run the program at a certain time, and then would return the results to the user probably hours upon days later. And so even the idea of users having to enter commands on a text-based terminal in real time was considered a huge radical idea back then.
The display system was based on vector graphics technology and could display both text and solid lines on the same screen. Because of limited memory space, it could only display uppercase characters. To display true uppercase characters, a short horizontal line was placed directly above any capital letters. Douglas hands operated 3 input devices: a standard typewriter keyboard, a 5-chording keyboard, which combinations of 5 keys could produce 32 separate inputs, enough for all the letters of the alphabet, and a mouse. The mouse was a small rectangle box about the size of a couple juice boxes with 3 buttons near the top connected to the computer with a long wire. Nobody knew who first started calling it the mouse, but the name stuck back then, and it has remained ever since. Mechanically, it was slightly different from the modern mouse in that it had 2 circular wheels connected to the internal pointometers rolled directly on the table surface instead of being manipulated by a single mouse ball rubbing against the rollers. However, to the end user, it operated virtually identical to a modern mouse. Other input devices have been tried, but this remains the most natural way to manipulate an on-screen cursor. With the invention of the mouse came the invention of the mouse pointer, which in this system was a stick arrow about the height of a single character pointing straight up. This was called the bug. When objects were selected by the bug, it would leave dots on the screen to mark this action. Many of the things demonstrated in the marathon session seemed to come from decades in the future, and most of the people watching didn't know what they were seeing. The demo featured hypertext linking, full-screen document editing, context-sensitive help, network document collaboration, email, instant messaging, and even video conferencing. It was all somewhat overwhelming, and due to limitations in the video system, it was sometimes difficult to tell what was going on. Douglas and his staff would continue working on these revolutionary ideas until the institute was closed down in 1989 due to lack of funding. However, there was never enough money to turn these ideas into commercial products.
Next, we'll be talking about Xerox and PARC. PARC stands for the Palo Alto Research Center, and essentially it was developed by Xerox because with the dawn of computers, they felt that their printing and hard copy business was going to be a thing of the past, and they wanted to stay competitive in the market. PARC was developed as a research center for computer scientists and technicians to work on various projects. Often the beauty about the center was that there was no specific goals, so the technicians pretty much had the opportunity to work and research on whatever they wanted to. One of their first important developments was the laser printer. And the printer was so advanced and so graphical that they needed a new computer actually developed in order for it to work. The Xerox Alto was first created in 1973. It was the answer to their question about the laser printer and being able to work with it in harmony. The graphics were of a resolution of 606 by 808. Unlike previous computers, the pixels could be switched on and off independently. It had a keyboard and mouse similar to the design of Engelbert. However, its software was rather, say, primitive. The display on the screen was 2 columns, and there really wasn't much you could do in the way of updating. So they they needed to improve their interface because of this, so they created Smalltalk. And Smalltalk was a type of coding language that allowed them to have a more complex interface, and it used program codes that could be called objects. And what programmers liked about the Smalltalk was it simplified their jobs, and it meant they had to do less work because of memory management. The first commercial computer that Xerox put out in the market was the Xerox Star 8010. It was first released in 1981, and it was a scaled down and not as advanced version of the Alto. The cons of the Xerox Star was that it was $17,000 and it didn't have a huge commercial success because of this, and it wasn't essentially as advanced with the growing technology. However, it did have Windows on the screen compared to the two boxes or tiles, and the funny thing is that the multiple windows, the software writers felt that the multiple windows would be too complex for the average person using the computer.
The most important of these graphic user interface pioneers was a small startup founded in a garage in 1976 by Steve Jobs and Steve Wozniak called Apple Computer. Apple has built its fortune on the Apple I, which was basically an assembled circuit board with no monitor, and the widely popular Apple II, which displayed both text graphics but had no traditional command line interface. Apple was a young company that found itself flush with money and was much more willing to take risks than most companies out there. Many former Xerox PARC employees, and PARC was the Palo Alto Research Center Incorporated. Many of the engineers from the Xerox PARC project found new jobs at Apple and set out to recreate their work on the Alto, but on a product that would actually see commercial release and potentially become pretty popular. Steve Jobs himself became a convert to the graphic user interface when his employees arranged a tour for him of the PARC facility. The Lisa would henceforth become a graphical computer, but the design of the interface was not yet set in stone. And the picture on the top is the 1979 design. That was the first interface design, and in 1983 that was the finalized design. Work on the Apple's next generation Lisa computer, which had started life as a traditional text-based command line computer for business use, was transformed by the influx of PARC employees. The Lisa team eventually settled on an icon-based interface where each icon indicated a document or an application, and also developed the first pull-down menu bar where all menus appeared at the very top line of the screen. Other ideas from the Lisa team included the idea of check marks appearing next to each selected menu item, and the concept of keyboard shortcuts for the most frequently used menu commands. The 3-button mouse, which had been changed to a 2-button design in the Star for simplicity, was further simplified to have only 1 button for the Lisa, as the interface required at least 2 actions for each icon, and the 2 actions were selecting and running. This concept of double-clicking was invented to provide this functionality. Work on the Lisa started in 1979, but the computer was not released until 1983. And despite its advanced features, the price tag was $10,000 US, and the difficulty of writing the software for the machines really limited the sales. However, the Macintosh project achieved the goal of a lower-cost graphical computer by shipping with a 9-inch monochrome screen, which was 512 by 384 pixels. It was only a mere 128 kilobytes of memory, which had no multitasking or even the ability to task switch between one program or the other, and it had one single floppy drive. It retained most of the graphic user interface features of the Lisa and even shared some of its low-level code, but the operating software itself was written from scratch to fit in the small memory footprint.